Hi, welcome to the next stoichiometry calculations video. Just a reminder, if you haven't, to have these steps in front of you so that you can make sure you can go through and do it reasonably easily. So the one we're going to be doing today is this one. All right, we're going to be calculating the concentration of a solution of copper sulfate. This is pentahydrate. So what this actually means up here is this has got 5 water molecules which are actually bound to the copper sulfate. Now that's really important, because when you actually go through and calculate the molar mass of copper sulfate pentahydrate, which is what we're going to be doing today, you must include those 5 waters in there. Okay, so what we've got is 10 grams dissolved in water to make 500 mils of solution. Okay, so this one's a little bit different because this is actually a example of where we're actually calculating a standard solution concentration. Okay, so we're going to be making a standard solution. We're not actually doing a titration in this case. We're just doing a calculation to determine a concentration. Alright, so what we've got here, we want to calculate concentration. Alright, if you want to know concentration, you need to know number of moles and you need to know volume. Okay, so in order to calculate number of moles, okay, we actually need to know the mass over the molar mass. Alright, that's from the N equals M over M function. So what we've got is we've got up here in our equation, we've got 10 grams, alright, dissolved. So we're going to be using that firstly to calculate number of moles. So number of moles equals 10 grams, 10.00, over the molar mass of our copper sulfate pentahydrate. So if you actually work that out off of the periodic table, check you can do this, you should work it out to be 249.69. Okay, so if you work that out, that will give you your number of moles. Okay, then you can use that to put into your equation. So concentration equals 10.00 over 249.69. There's our number of moles. Okay, we're going to divide that by our volume, which is 500 mils up here. Okay, 500 mils. So we actually want to make sure we convert that into litres for the intents of our calculation. So it's 0.500. Okay, put that all in your calculator and you should get a value of 0.08. Now what you might be tempted to do is just leave it at that. Okay, but what you've got to do is come up here and have a look at your question, and up here we've got 4 significant figures for the 10 grams and we've got 3 significant figures here for the 500. Now this one here is always a bit tricky. We don't know if the zeros to the right of the 5 are significant or not. That's always a little bit more difficult to tell. So for all intents and purposes, we're going to take them as significant. So that's 3 significant figures. So what that means for us is we're actually going to give our answer to 3 significant figures. So it's going to be 0 moles per litre for our concentration. Okay, so this is just a bit of an example of how you calculate a standard solution. Normally when you are dissolving up a solid into a volumetric flask, calculate concentration, and you can use your significant figures to get an answer as well. Alright, hopefully this helps you guys. Move on to the next one. See ya.